All right, fourth graders, today we are on Module 5, Lesson 7, and we are going to continue decomposing with area models, and we're going to add in a new little piece. So when you're done with your table of contents, you can flip to our first page of notes for today, and we'll check out our objective. I also made a mistake, so you're going to have to scribble out 6 because, whoopsies, it's really Lesson 7. So sorry. So here's what our objective says. I can decompose fractions into smaller equivalent, I put my equal sign, fractions, using an area model and multiplication. And so the big part today is that we are finding equivalent fractions. So we need to figure out how are we going to do that. So I know that here's my fraction. I have the numerator and I have a denominator. If I want to find an equivalent fraction, remember that means that it's equal, I am going to do a couple of things. We are going to multiply the numerator and I want you to circle, even though it's capitalized, we have to draw our attention, the numerator and the denominator by the same digit. Okay, so we're going to see what that looks like because our objective says that we can use area models and multiplication to find those equivalent fractions. So that's what we're going to do. The first thing I'd like you to do is shade this area model, and we're going to record 1/3 in our area model. So I'm going to go ahead and start shading 1/3. Okay, and so I know that this part is 1/3. And now it says, now I'm going to draw one horizontal line across our area model. Remember already we had practiced decomposing our area model this way because now I have something different. I have a new fraction. My blue shaded spot was 1/3. Now I didn't change any of my shading. I didn't add in more shades. I didn't take anything away. I'm going to just lightly come over this part because now instead of 1/3, I have 2. I need to figure out what my denominator is. I'm going to count all the pieces I have together now. 1, 2, 3, 4, 5, 6. So now my brown section, that same space can also be called 2/6. So I have found that 1/3 is the same space as 2/6. We did that yesterday. But let's look at how I can show that using multiplication. So if I start with 1/3, and I'm going to multiply, remember up here it says that I can multiply the numerator and the denominator by the same digit. So I know already that my ending fraction was 2/6. So what did I do? 1 times something gave me 2. Oh, 1 times 2. And if I did it on the numerator, I have to do it at the denominator, so that means 3 times 2, and that indeed equals 6. Now the reason that I multiplied it by 2 when I look at my area model is because I took one piece and I turned it into 2. So I made those equivalent fractions. That means that 1/3 is equal to 2/6. So let's talk about what happens to our fractions for just a moment so we understand. When I talk about the size of my fractional unit, so that means from 1/3, and now I went to 6 pieces. What happened between the 1/3 and a 6th? If you think that my unit, the size, got smaller, you are correct. That piece got smaller, even though the denominator went from 3 and it changed to 6. That doesn't mean that my piece got bigger. It means my piece actually got smaller. Think of it this way. If I invited 3 friends over to share a pizza, the pieces are going to be bigger than if I invited 6 friends over to share that same pizza. I'm going to have to cut my pieces smaller when there are 6 of them instead of 3. So when my denominator is the bigger number, the piece of my fraction is actually smaller. Okay. Now let's think about what happened to the number of units in the whole. So that means what happened to the denominator? Well, when I went from 3 to 6, my denominator got bigger. And really, from 3 to 6, it doubled because I multiplied it by 2. So when I multiplied by 2, it doubled the denominator. Now it says what happened to the shaded number of units. That means I'm talking about my numerator. Well, I multiplied it by 2 as well, so it also got bigger, and it doubled because I multiplied by 2. So we have to think about what happens to those, oh my goodness, friends, I spelled that wrong, multiplied by 2. We have to think about what happens to those parts of our fraction when I'm finding those equivalent or equal fractions. So we're going to keep practicing and try some more before you go ahead and work on your own. So go ahead and turn the page for me. So now I have some directions that say find 2 equivalent fractions for this original area model. So I can see I have an area model here, and it's the same down here. So we're going to do one set up here, and then I'm going to find another equivalent fraction because my directions say find 2. All right, well, I need to first decide what fraction is being shown by this area model. So I already see that there's 1 shaded, and now I need to determine, well, what's my total number of pieces for my denominator? And I see 1, 2, 3, 4. So this area model is showing 1/4. Now, I want to find what's another way that I can name 1/4. And so I'm going to think, and I'm going to go ahead and I'm going to decompose this area model with one line down the middle. And that turned my 1 piece into 2 pieces, which means I multiplied it by 2. I took my 1 piece, I multiplied it by 2, and it gave me 2 shaded pieces. Now I know that when I am trying to find an equivalent fraction, whatever I do to the numerator, I have to do the same thing to the denominator. So that means over here I'm going to say 4, because that was my original denominator, times 2, that's what I did up here at the top, equals 8. Now I'm going to count and use my area model to make sure that my fraction of 2/8 is correct. So I have 1, 2 shaded pieces, that's correct. Now let's count how many I have in total. 1, 2, 3, 4, 5, 6, 7, 8. Well, it worked. So that means that 1/4 equals 2/8. That is the same amount of space. And I did that by multiplying the numerator and the denominator both by 2. But now I need to do that again, but find a different way to have an equivalent fraction. So this time, instead of drawing 1 line to decompose this area model, I'm going to draw 2. And that means that it turns into, let's count how many. Before, I already said I had 1/4. Now I've drawn 2 horizontal lines, and instead of 1 shaded piece, now I have 1, 2, 3 shaded pieces. That means I multiplied 1 times 3. And I know that 1 times 3 is 3. But I know that whatever I do to the numerator, I have to do the same thing to the denominator, because I decomposed all of these pieces. I didn't stop at the shaded space. I drew my decomposition all the way through. So I don't have 4 pieces anymore. Now I have 4 times, oh, I'm thinking if I did times 3 on the numerator, I have to do times 3 at the denominator. And I know that 4 times 3 equals 12. So 1/4 is the same and equal to 3/12. I can see that my shading never changed. Those pieces are equivalent. Excellent job. Now this time we're going to find 2 more ways to name each fraction, and this says without drawing our area model first. So that means I'm really going to focus on this step of multiplication. So we're going to start with 1/3. So I'm going to rewrite my fraction. I'm going to make kind of a longer fraction bar because I know that now I'm going to be multiplying. And I know that whatever I multiply on the top, I have to multiply on the bottom. So I'm going to start, and I'm just going to pick number 2 to multiply it by. And so I'm going to say 1 times 2 and 3 times 2. And now I'm going to have an equivalent fraction. So 1 times 2 is 2, and 3 times 2 is 6. So I know that 1/3 equals 2/6. But I can't finish because I need to find 2 new ways. So I'm going to start another one, and I'm going to say 1/3 equals, well, I want to find a different way to do it. So I know I'm going to multiply my numerator and my denominator, and this time let's pick 4. So I'm going to find an equivalent fraction to 1/3, which 1 times 4 equals 4, and 3 times 4 equals 12. So now I know that 1/3 is equal to 2/6, which is also equal to 4/12. All 3 of these fractions are equivalent. That means they take up the same amount of space on an area model. Excellent job. We've got 1 more to try. This time we're going to do 1/5. So again, I'm going to start by rewriting my original fraction. And I make that longer bar because I know I need to multiply. And I know I have to multiply by the same digit on the numerator and the denominator. And I'm going to try 2 again. It's always a safe bet, 4th graders. And so that gives me a new equivalent fraction of 2/10. But of course, I have 1 more way to find an equivalent fraction. So I'm going to rewrite 1/5 with that longer bar so I can multiply. Now, 4th graders, if you're thinking, well, there could be a ton of ways to find equivalent fractions, you are exactly right. This time I'm going to go with 5. And I'm going to multiply the numerator and the denominator by 5. And now I have a new fraction of 5/25. And here's what I want you to remember. Earlier on the first page, we said that as this denominator gets bigger, the piece of fraction is actually getting smaller. So 1/5 is equal to 5/25. But if I had 1/5 and 1/25, this piece is going to be much, much smaller than this piece because my denominator has been broken up and my area model has been cut into all those pieces. Nice job today using this new multiplication strategy for equivalent fractions. Go ahead and practice on your problem set.